In this video, we will show you how to build a simple row calling app that has two view controllers. The first view controller will have a label corresponding to with the current name, as well as two buttons allowing it to select whether that person is present or not. And after we've gone through every name, we will be taken to another view controller where we show all of the names selected, as well as a reset button allowing us to go back to the previous screen. Remember, both the starter code and the complete project is available on GitHub. All you need to do is just run the command specified on the website and merge to your local branch. All right, so let's get started. First, let's run our starter code. Right now, it won't display anything because we haven't added anything to it yet. Although there are a lot of the skeletons provided, we haven't actually added any subviews, as you can see in our view.load function. So the first thing we're gonna do is to add these two buttons as well as the labels to our subviews, to our view hierarchy. So remember, to add the subview, we need to call view.addSubview, the addSubview method of the root view, which is a view view. And then we want to give it the view that we wish to add it to subview in its parameter. And let's do it for all three of the subviews, present buttons, as well as the absent buttons. Oh, sorry. And after we're done adding our subviews, we also need to create the constraints. Because right now, since we initialize it without the translating automated masking to constraints, we can't use our frame-based layout. So in order to create constraints, you simply need to write your constraints in an ns_layout.activate. Remember, there's always another way of writing every constraint and then say .isActive equal true. It is equivalent of saying ns_layout constraint.activate plus your constraints. The benefit of using this method is that you'll be able to create constraints relatively quickly in bulk. So let's first start by adding the top constraints for our name label. What we're going to do is we'll say name label.top anchor. So we're referencing the top anchor of the name label.constraint. You see, a very key thing for adding constraint is to always take a look at the auto-completion. The auto-completion provides all of the available functions or methods for you to use. So for example, in this case, we want to constrain to the top anchor while leaving a bit while giving it a bit spacing, which is a constant. So we're just going to select the second option, equal to some anchor, and then with the constant c. If we hit enter, this will auto-populate the rest of the function call. We only need to add the parameter. So the first parameter is equal to, since we want to pin our name label's top anchor to 200 pixels away from the top anchor of our screen, we just need to reference the top anchor of the view. However, in this case, we actually don't want to just simply use the view because in iOS, we have something called a safe area. If you take a look, if you have an iPhone right now and it's iPhone 10 Plus, you'll notice the top portion of the very top portion of the screen, you have this camera assembly. And that place you shouldn't technically place your view components on it because it will be covered by the camera assembly. So in iOS, there is something called a safe area layout guide. That's basically the edge of the screen with the safe area inset. With the safe area inset, it means that basically the top will shift it down a little bit to account it for the very top portion of the screen. So we're gonna use safe area layout guide.top anchor. And then with the constant, we're going to say 200. So remember, this positive 200 means going to the white anchor where the white anchor is pointing at and going to and the space, put 200 points spacing on it. because the origin on an iOS device in UIKit is the top left corner of the screen when we are on the portrait mode. This means this top anchor plus 200 will go down 200 points, and then this will be where our name label.top anchor will be. So basically this creates this little constraint right here on the very top. So remember to add the comma after the first constraint, because this is essentially a list. After that, we want to add the leading anchor of our name label, and this is basically just going to be the same technique. Instead, this time we don't really need to reference safe area layout guide, because like the side of the screen doesn't really have a safe area. We can safely use view.leading anchor. And similarly, we want to provide a constant, which is 50. After that, we want to do the same thing for the trailing anchor. So name label.trailing anchor .constraint equal to view.trailing anchor, constant is -50. So here you can see the difference between +50 and -50, because it's essentially pointing to the different direction of our like the coordinate system. So -50 simply means towards the left. And after that, we want to set the constraints for the two the buttons at the bottom, at the second half portion of the screen. So we'll say present button top anchor .constraint equal to name label .bottom anchor .constraint when equal to 300. So this will create this 300 spacing right here. And then we were going to do the same thing for the leading anchor .constraint equal to view.leading anchor, constant is what's the design here? It was 80. And we also wanted to create the same thing for the other button. So we're gonna say some button .top anchor .constraint equal to name label .bottom anchor, and the constant is also 300. However, for this one, for the present button, for the absence button, we wanna pin the trailing anchor to the right. Right? And this will be -80. So now there is one thing left, which is the middle spacing between the two buttons. So right now we have this, the 80 points for the leading anchor of the present button, and the -80 for the trailing anchor of the absent button, which will be on the right. But we still haven't got the middle 120 spacing between these two anchors, which we're going to do right now. So here is another anchor that you probably haven't heard of, which is the middle, the center X anchor. So the center X anchor is essentially this axis right here. It will be very similar to the leading anchor and the trailing anchor. They're both X anchor. Notice that if it's horizontal, it's called Y anchor. If it's like vertical, it's called an X anchor. S anchor can only be constrained to an X anchor, because otherwise, it doesn't make sense, right? So here, what we're gonna do is we're gonna say the trailing anchor of present button will be the center X anchor of the view -60, right? So this will create this this small constraints right here. So we're gonna say present button dot trailing anchor dot constraint equal to view dot center X anchor -60. So if you keep in mind where the origin are, it's like pretty relatively easy to figure out like when you should use positive and when you should use negative. only you should remember that this constraint equals is something like an equal sign. So what I'm actually doing right here is present button dot trailing anchor equal to view dot center x anchor minus 60, right? So in the pseudocode, it will look something like this. And that just helps you memorize, when you should use positive and you should use negative. So the next one will be the leading anchor of the buttons on the right, which is this one, which is absent button. The leading anchor constraint equal to view dot center x anchor, and then this time it should be positive 60, right? So now we have all of the relative positioning constraints set. There is this final piece of the puzzle is the height of these anchor. So we don't need to set the height for the label because remember we talked about this before, like the label's height is intrinsic and you can be inferred from the content of the label, like the line number plus a number of lines plus its the font size. However, for a button like this, because we want to be able to use its background, we can just like not give it a height. Especially as you can see later on, we want to make this button round. I don't know whether you guys pay attention to the demo a completed version of the app we showed in the beginning of the video. But these two buttons essentially are gonna have equal. The width of this button is going to be equal to its height. So the final piece of constraint we're going to set will be pinning the width anchor of each button to its own height anchor, right? Because the width can be determined by these 4 constraints. However, the height is sort of still like undetermined, right? So what we're going to do is to set its height to just equal to whatever the width are. So here we're gonna say present button dot width anchor dot constraints equal to. Notice that we don't need a constant this time. We could just say equal to something to its own present button dot height anchor. You can interchange these two. You can like say present button dot height anchor constraint equal to present button dot width anchor. The order usually doesn't matter. And after that, you can say absent. Do the same thing for the absent button dot width anchor dot constraint equal to absent button dot height anchor. So this should be all of the constraints that we need for our view. Right now we can run it real quick. However, we should first finish the styling, because otherwise it won't be very clear what we have accomplished for our constraints. So let's just also finish the styling for our UI components as well. The name label, UI label is already finished for you, but the buttons configuration is not. If you scroll to the top a little bit, you'll see a lot of the UI components created for you. Actually, these should be private, but let's just leave it like that. It's fine. First, we have the absent button. Well, let's run the completed version again and see what we're trying to do here. So you see, we are trying to have this check mark and this this X mark with a green background, a red background, and the button should be rounded. The first thing we're gonna do is this little inside image right here. This is usually done because the image we don't need to give a check mark image. It's already built in the system. There is a special set of image called the SF symbol, where you could just use in your iOS app. And to find SF symbol, you first need to download this app. I believe this is available in App Store. Once you got in here, you'll see like a bunch of like icons like that, and you could just search. So if I want a check mark, you can search check, and it should show you like a check mark. So this name is very important. This will be the name where you reference the image. So for example, for this button right here, we're gonna say set image, and inside this image, because whatever like SF symbols are provided through the UI image class, we're gonna say UI image the system name, and this system name is basically being a name that you got from the SF symbol. So this one, because it's absent, so I remember it's X mark, right? Yeah, X mark. So you see, I can search X mark, and you'll see the X mark here, along with the other X mark if you want to use that one. So we're just gonna say X mark, and for UI control state, we just say normal. So the reason why we have like multiple different states is like the button can have, like when you're pressed, it's a different state. When it's just standby, it's a different state. Usually we just need to set it to normal. And because we now set the image, we still want to configure these image, because as you can see, it has like different style. Like, I don't know whether you can see it right now, but essentially it has, a bunch of font weight, the weight of the font, and as well as the size of the font. And but however, it's an UI image, we can't just set it with a UI font that we will do for the title. We have to do something special called the symbol configuration. So to create a symbol configuration, I guess you can skip through this part if you're not too interested about how to do it. You don't need to know how to do it in order to finish the project. However, to create it, we just call UI image the symbol configuration, and inside this configuration, you see the point size. There's like a bunch of initializer. One of them is a point size and weight, which is the one that we're gonna use. So weight.medium, and once you create a symbol configuration, we still need to activate it. And it's activated through button.setPreferred symbol configuration. And here the symbol configuration is the one that we just created. For image in, and again, this is a control state, we just need to set it to normal and should be fine. Next, we want to set the tint color. The tint color, there's like a bunch of different colors for a UI label. First, we have this background color, which will be set to red, and also there's this tint color that dictate what the color for the icon, for the logo, this UI image is, and there is also the title color, which will be like where the text of the buttons, what's like the color of the text inside this button. However, because we're using symbol, and the symbol is an image, and it's set through the tint color. So we're gonna say button.tint color equal to white, right? Next, we want to set the background color. It's very simple. It's basically the same as everything else. You just say background color equal to system red. Well, system red is a bit different from just red, because system red is adaptive. And as you see in the comments, you can open the quick help menu by clicking a property or anything else while holding option key like that. It says a red color that automatically adapts to the current trade environment. And this will be our absent button. And next, we're gonna do the same thing for the present button. All right, so we have done the same thing for the present button. Right now, let me see. We should be able to run out. Oh, there is a final thing to do, which is this view will appear. So let's take a look at how the names are handled here. We have a constant that's always going to be the same because it's a constant that stores all of the names, and we also have a name to call list, which will be the names remaining in that list, as well as the present names and the absent name that stores the name that we have selected. Right? So every time we enter the app or every time we want to reset, we should be able to populate this name to call list with the shuffled version of the name. Reason why we want to do it in view will appear is because we have this result VC that will have a reset button on it, and when we reset, we'll go back to the roll call VC, and this roll call VC should be able to pull from the names list again and repopulate the names to call. However, if you remember, we talked about it in the previous in lesson 0. One thing for view.load is that it's only going to be called once when the view controller is loaded into the memory, right? So when you go back from the result VC, what you're actually doing is not reinitializing a roll call VC. What you're actually doing is just bring it back into the top of the user interface. The view controller itself stays in the memory, so it's never reloaded. So the view.load will not be called when we come back from the result VC. However, view will appear will be called because view will appear is tied to the lifecycle, to the presentation lifecycle, where it will essentially be called every time it's bring back to the top of the view stack. So if we do the population here, we'll be able to reset every time we come back, right? To populate that, we just need to say name to call equal to names dot shuffled and name label dot text. Because this repopulates it, we still need to give it the last one and pop it from the list. Names to call dot pop last. Okay. So if we run the app right now, we should be able to see the UI. However, the button shouldn't work, as well as the rounded edge, because we haven't set that yet. But now you can see we have the buttons with the check mark and the X mark in it. Actually, the X mark looks sideways. Is it? No. And also the first names are correctly displayed in our label. Next step what we're gonna do is to make this button round. There's actually a little trick to it. In iOS, there is something called a UI layer, and UI layer has a property called corner radius. What we're going to do is to set the corner radius to be half of the width, because the width is equal to the height. If we set it to half the width, we'll be able to create this rounded background. So we're saying present button dot layer. It's a CA layer, not UI layer. Dot layer equal to corner radius, and a corner radius equals to present button dot frame dot width over 2. And we're going to do the same thing for the absent button. Dot layer dot corner radius absent button dot frame dot width. Now you might be wondering why we're doing this in view did layout subviews. The reason being it's because of its frame. So remember, we initialize our UI label with a 0 frame, and when view did load, the 0 frame is still there because we have just set our constraints. If we write these two instructions in our view did load, our UI label hasn't got a chance to resize its layout. The frame is still going to be 0. The width is still going to be 0. We will be essentially setting the corner radius to 0. However, in view did layout subview, this lifecycle function is called after subviews have finished the layout, meaning that the frame will now correctly reflect the frame of this, right? Because right now the frame has been calculated from our constraints. So if we do it here, we'll actually be able to get the correct frame. We won't if we set it inside our view.load. That's the reason why we set it in view.layout subviews. So if we rerun it again, we should be able to see our rounded button. Now, we haven't added the logic to the button yet, but let's just take a look at how we did it. There is similar stuff in the project. So basically, if you have a button and you need to tie the callback to that button, you need to use add target. So the add target looks like this. The button that you're using, .add target, and this function, this method will take 3 values. The first value is the target, which usually be self, and the second one, which is the one that really matters, is a selector. So the reason why you're using an Objective-C function right here is because of this selector, because selector only works for Objective-C. And this Objective-C notation is sort of the way of delegating that, making this function interface, this interface available for the Objective-C runtime. So in this selector, you're going to type selector, and in the selector you will type the function signature. And after that, you are going to designate which event that this function, this callback should be binded to, and in most cases, it's going to be touch up inside. Touch up inside simply means you press the finger inside the button, and you lift your finger inside the button as well. So this will be the usual case for a touch event. There is something like touch up outside, which will be like press the finger inside and then move it outside and lift it. So that will be like a different thing. Usually you just want to add it to touch up inside. Right now our absent button and the present button is added to the same callback. That means whenever we tap either of those, it will call this did-tap button function right here. And right now it's not linked to, it's not doing anything. It's just using UI view.animate to fade in and fade out the view. But we're gonna change that real quick. So because it's tied to the same callback, we sort of need a way of identifying like which buttons, initiate this callback, right? Otherwise, we won't know which of these two lists we should be appending our name to. And luckily, we have something called a tag, and we already set it here. A tag is essentially a integer associated with a button. It's often used to identify a button among many other buttons, or even among other views. So in this case, we set our present button's tag to 0, and absent button's tag to 1. So we'll be able to use it to identify which button it is inside our did-tap button function. So we're going to use an if statement. If sender, the sender will be the the UI button that sends this that initiates this callback. So we're going to say sender.tag. If sender.tag equals 0, we want to say present names dot append with the new element name label dot text. Notice that name label dot text is an optional. However, because we are confident that every time we access this name label dot text, it won't be a nil, right? Because we've set it to a real values all along, we can safely force unwrap this, and it shouldn't cause us any trouble. And if it's not, we just need to append it to the absent names, like that. Name label dot text force unwrap. And then finally, we want to get the last name, the last item in the name to call list, if there is one. But however, if we run out of the name, this statement, the name to call pop last, will actually returns nil. So we want some sort of mechanism to be able to handle that, right? Because if name to call pop last gives us no, that indicates that we should go to the result VC instead of continuing popping that list. So we're gonna use a guardlet statement. Names to call dot pop last. This will give you the last of the list, and we'll remove that last item from the list. So if this conditional assignment failed, meaning that if there is no items to be popped, we will present result, which is a function right underneath, and return, because guard statement cannot false through. So after that, we will go into this view.animate. In this animation, we first set the alpha to 0. The alpha just means the opacity. Opacity to 0 means this is going to be transparent. And it's inside UI_view.animate means that it will animate from whatever its previous value is in 0.3 seconds to 0. So this will be the animation. After animation, there is a completion. This completion will be, be called after the animation. Here we want to switch the name of the name label from whatever its previous value is to the next name that we just got from the name to call that pop last. And after that, wait a second. Oh yeah, we have to use explicit self because it's in a closure. And after that, we're gonna reset it to alpha equal to 1. So 1 just means completely intransparent. So also in 0.3 seconds. So if we run it right now, we should see the names changing with a fade in and fade out animation. So UI_view.animate is very versatile. You can animate a bunch of different things inside the animation block. You just the way you use it, you just you write whatever you want to change, whether it's a color or an alpha inside this animation block, and UIKit will animate that for you. Normally people animate something like alpha or the background color or even a constraint. If you use a constraint, you remember, actually we should talk about it a little bit later, it's too complicated right now. You just remember that if you want to animate alpha or color, you just write an animation function. And remember this guardlet statement, if there is no item to pop, we'll go to the present result. And inside this present result, we'll first initialize a VC, which is a result VC. If we take a look at result VC, we'll see that there's two lists to be populated. There's the absent name list and the present name list. So once we initialize, actually, why do I have so many result VC tab right here? Okay. So once we instantiated the view controller, we should transfer the data from our property into the result VC's property. And this is usually how you will translate. This is the first approach we learned of transferring data between view controllers. So what's the list name? It should be absent name, right? And VC.present name list equal to present names. And VC.model presentation style full screen just means that just set the presentation style of that view controller. If you use a full screen, you'll see this will be pushed from the bottom to the top and covers the entire screen. If you don't set it, it's usually just a sheet where you can just scroll down and go back. You should change that and see how that looks. However, I don't think you'll be able to see much because it's black background. I remember there's a problem with our starter code for the project where this one is set in the view.load function of the target VC, and that won't work because view.load function will be called after the present is actually executed. So in order for that to work, you need to change that from the view.load to before the present method. But that's just for the project. So now if we run it again, we should be able to go to the next screen once we've gone through all of the names. Let's go. Right. However, because we haven't done anything to populate to use the present name list, we still can't see the results. But there's just two simple lines of code that we want you guys to write here. It's in this well-set function. Actually, this is not a function. It's called a property observer. It's basically a chunk of code that will be executed every time the property it observes is set to a new value. And its syntax is like this. You write the declaration and the initialization, or you can also not write the initialization and make an initializer that initialize these property. But what you want is this curly braces right after. So this will be inside the curly braces. You'll use a will set keyword, and in the will set keyword you will define your the function, the code chunk that's tied to the will set property observer. And in the will set property observer, let me just hold it up real quick. In the will set property observer, you'll have access to this special keyword called new value. Because it's will set, it hasn't been set yet, this new value will be tied to the value that it's going to set, that's going to assign to this property that it observes. So what we're going to do is just say text equal new value dot joined separator string, like that, and we will uncomment this. So this will use it and use that to append the text, which you will have converted from an array of string into a single string separated with this comma and the space. And if we run it right now, actually let's just finish the present name list as well. So as an alternative to will set, you also have a did set. It's very similar to a will set. The only difference is it happens after the property has been assigned. And then instead of a new value keyword, you'll have this old value, this old value keyword that stores the previous value of the property. Then you might ask, like, then what's the current value of the property? Well, it's because it has been set. You can just reference it using the property name, like that, and we'll do the same thing. Say join separator is comma space. So if we run it right now, we should be able to see the text, the list being populated into the name label as an attributed text. So if you don't know what an attributed text is, I think I talked about it in the debugging guide video. It's like a little trick. Is not something that's super important. It's just like a little trick that can make your UI looks way nicer. Actually, what happened? Oh yeah, we haven't added to the subview. We're gonna do that real quick here. But yeah, we talked about it in our debugging video. So yeah, it's just not something super important. It's just something that will make your UI looks nice. Well, before we add it to the subview, there is another thing to talk about. That's called it's a UI stack view. So you've probably seen like how difficult it is, or how tricky, or like how much work it is to manually write out every single constraint, right? But however, you don't always need to do that, because sometimes you just, in the case of a simpler UI, you just need something to, like, your UI to stack on top of each other. So there is another nice layer of abstraction called a UI stack view that sort of does that that sort of does that for you. UI stack view is a view stack with a self-managed layout. What I mean is, you just need to set the layout for the UI stack view, and whatever is inside the UI stack view will manage that for you. So you don't need to set the constraints for whatever is inside the UI stack view, right? You just need to set the constraint for the stack view itself. To see that in action, we first need to add a subview to the root view of our view hierarchy, just as any normal UI view. And what's next is we're gonna add our UI components as an arranged subview of that UI stack view. So we're gonna say main view stack dot add arranged subview. Add arranged subview is sort of the unique method that's only available for a UI stack view. And first, you can say and the order for which you add these UI views, these UI view components, will be the order where it appears inside the stack view. So I think this is best illustrated when it's in action. So let me just add everything to the stack real quick. Now we have added everything to the stack, and like I said, we only need to set the constraints for the stack view. For this one, we're gonna pin it to the center of the screen. Pin the whole stack view to the center of the screen. So you just say center view.center x anchor dot constraints equal to the stack view center x anchor, and the views center y anchor. We go to the constraints. We constrain to the stack view center y anchor. Center y anchor. And finally, we also want to set the width of the stack. Equal to constant. Notice that equal to and equal to constant is a bit different. Equal to is used between anchors and anchor. Equal to constant is used between anchors and constant. So for this one, we're gonna say view.bonds.width times 0.75. Well, I'll talk about why we can get away with not setting the height for the view stack a little bit later. Let's just see how it looks like. As well as we're going to go through the list. Right. So you see these view components that we added are stacked on top of each other inside a stack view. So if we use our capture view hierarchy tool right now, we'll see this background is our UI stack view, and all of the components are arranged inside that stack view. They are stacked on top of each other. That's the nice things about stack view. You don't need to set all of the constraints for the three view components. You only need to set a constraint for one, which is the stack view, right? And let's take a closer look at what the stack view looks like. First, a stack view is initialized the same ways as every other view components. You can initialize it using a closure. Inside the closure, as always, you'll have to instantiate a stack view first into the stack, like we did for the label or the buttons, and then finally you want to return it. However, there is a couple of special properties need to be set for the stack view. First is its axes. Here you see the axis of the stack view is equal to vertical. That just means that the stack direction, the stack flow will be the vertical axis. So everything will be stacked on top of each other, versus if you use a horizontal, everything will be stacked next to each other. And next we have this distribution, and this is important because For the distribution, we set it to equal spacing, and we also set the spacing to equal to 40. So that means every view will have 40 will be 40 points away from each other. And because every view that we set right now, its height can be inferred from the content, we don't need to set the content for the entire stack view. Like you see right now, like this UI label height is inferred from its let me pull the pin. Actually, how do I zoom? Oh yeah. So I see this UI label, the height of this UI label, it's determined through its line number of lines, and the font size. So you don't need to set this height is set, as well as this one. And finally, the height of this button is also set because we use a title. So along with the spacing, which is 30 points that we set, this entire stack view's height can be determined. That is why we can get away with not setting a height in our constraints. However, if you use distribution like fill, you'll have to set it, because the stack view will actively trying to fill the remaining space of your stack view. And if you didn't set how big the stack view is going to be, it don't know how it does, like the stack view doesn't know how much it's going to fill, right? So if you use equal spacing, that's sort of the nice side effect of it. And finally, just as every view that use auto layout, you want to set the translate auto resizing max into constraint to false. So I believe this is all for our demo. I highly encourage you to try these out. Going through the video and try these out yourself, because you'll be using a lot of these concepts in your project. But yeah, a final note: you can go back from a view controller that's presented using the present function through this dismiss method. So if you present, it will pop the view controller on the top, and if you call dismiss on the top view controller, it will dismiss that view controller and go back to the previous one. That's sort of like the reverse action for present. Is just dismiss right here. All right, that's the end of the video, and I'll see you next time.